For this course, I'm going to be using IntelliJ as the IDE of choice, but you can use any other IDE such as NetBeans or Eclipse or even VS Code if you wish to do so. But you'll see that if you use the exact same IDE, then you'll have no issues running and completing all the exercises. So here, navigate to jetbrains.com/idea and download. So in here, you can either download the Ultimate Edition or the Community Edition. So download either. And you can see that they also have for Apple Silicon if you have a Mac with M1 chips like myself. So go ahead and download and install IntelliJ. And also, actually, let me just mention that. So yeah, so right here, I think it's better actually for you to install using Toolbox. So get the Toolbox, and then here you can actually install all of the other IDEs and also update IntelliJ with no issue. So you can see that you can update automatically, rollbacks, downgrades, so on and so forth. So give that a go and make sure to use IntelliJ so that everything works without no issues. So in order for you to get started with this course, I already have all the examples and the source code prepared, which I would like you to use. So navigate to this repo, github.com amigos code /java-streams. And in here, I do have this README, but more important, you can see that I do have two branches. I've got main and start. So let's together clone this. In here, we can just basically grab this, and then you can either use HTTPS or SSH. So let me just grab this, Command C, and I'm going to open up IntelliJ. And in here, I'm going to say get from VCS, and we can pass the URL just like so. And I can basically say clone, and I'm going to clone into users amigos code idea project Java streams. So clone, and I'm going to trust everything under this folder, and there we go. So you can see that I successfully cloned the project. Here, if I close that, so what I want to do is in here, have a look. We have two branches in here at the very bottom right corner. So we have main and start. So I'm not going to switch just now. So what I want to do for you is I want to open up the main folder, so Java streams, and inside I only have src and then test and then Java. So all the examples for this course will live inside of the test folder in here. So this is a Maven project that contains all of the dependencies that you need. So what I'm going to do is I'm going to right click in here. So right click under Java, so this green folder, and then run all tests. And you should see that everything should just work. So there we go. And these are all the examples that you will cover throughout this course. So 38 tests did pass. Now let me hide this. And before I explain what's inside here, what I want to show you is inside of pom.xml. And inside I do have this XML, but what I want to show you is I do have JUnit, Guava, Assert4j, JSON, and then commons.io. So if you don't know about testing and you want to learn about unit testing, integration, mocking, all that stuff, I do have a course on testing. But these are all the dependencies that we need for this course. And also I'm using Java 17. So here, if I go to, I think it's under file, and then open up project structure, and right here have a look, project SDK, and then open JDK 17. So if you want to follow along with 17, this should work, or any other version. So here all you have to do is click on edit, and then click on plus, and then download JDK, and then select Oracle OpenJDK 17, and off you go. So to be honest, this is pretty much the setup that you need for this course. Next, let me walk you through these folders in here. So beans, examples, and mock data. So in here, I'm inside of this main branch. So this is the examples that you will basically complete at the end of this course. And let me quickly walk you through this package in here. So beans, examples, and mock data. So beans contains pretty much the models that we're going to use for this course. So a car class, a person class, and a person DTO. Now these two classes, so car and person, they basically are part of the mock data. And mock data, so mock data, if I open this up, so this here gives me a list of people and a list of cars. Now these are JSON arrays that can be found under resources. So cars.json, so this is a list of 1,000 objects or 1,000 cars, and the same for people. So then I basically just load them inside of this list and then return it back so that we can use it in our tests. So if I open up the examples, let's look at statistics with stream, for example, right? So here you'll see that you have this first line in all of the tests, and you can see cars, and then we just use it. So here we basically say mock data, and this is a static method. So we just have to say mock data get cars, and then we can use it. So the same throughout all of these methods, you'll see that we are using either cars or, so here I can say person, right? So get people actually. So there you have it. Now what I need to do is, so if I close everything, go ahead and open up in here. You can see that my cursor is right here and I'm navigating to the lower right corner, and I'm going to click on main, and I want you to check out this branch. So origin and then start. So check out, and what this will give you. So in here, so have a look. If I open up distinct and set, you can see that, oh, actually, let me open the same file. I think it was map and reduce. Have a look. All of that code is gone. So throughout this course, I'm going to be telling you, right, so open up this file, for example, or this class, and then you can see that I'm using people here, and then we'll basically use these classes for learning streams, and you'll see all of the examples instead of you having to write all of these tests and classes, which there is no need. So make sure that you check out the start branch so that you can follow along throughout this course with no issues. If you have any questions, please do let me know. Otherwise, let's kick off our journey in learning Java Streams. What exactly is the Java Stream API? Well, to understand that, let's focus on the stream itself. And in this course, we're going to fully learn what exactly is a stream and how it works from top to bottom. So a stream is pretty much an abstraction, and it focuses on the overall picture instead of each individual part. So when you build an application, sometimes you pretty much just write a bunch of logic. So if this, do that. If not, do that. Otherwise, use a switch statement, so on and so forth. Create an empty list. Do this, do that, right? So that is the individual pieces, right? Whereas the stream focuses on the overall picture, and instead of us defining the implementation as a whole, we pretty much just tell it what we want. So to understand what I mean, so have a look at this piece of code. And by the way, don't worry too much about this because we're going to go over all of this in detail. But in here, check this out. So this is imperative approach, or the imperative programming, where we specify every single implementation detail. So have a look. We have a list, another empty list. We have a limit. We have the counter. We loop through the list. We have an if statement. We add to the list, and then we increment the counter. Then if we reach the limit, we break. And then at the end, we pretty much just print out the contents. But you can see that this is a lot of code for something very simple. But this is because we are focusing on the individual pieces, right? So individual parts. So we as a developer, we have to implement everything. And this sometimes can lead to a lot of errors and bugs. And instead, with streams, which allows us to move from imperative to declarative programming, we can rewrite the entire thing. So have a look. So how many lines of code in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 lines or 20 all together, right? So we can replace all of this with this right here. So have a look. Just this. And this is what you're going to be learning in this course, right? So have a look. Here we're not defining the if, we're not defining an empty list, we're not defining how to increment, how to stop, so on and so forth. So you can see that we have a list, we invoke the stream, we filter, we tell it how many we want, and then we collect back to a list. Job done. And don't you worry about this if you don't understand, but at the end of this course, you will know everything there is to know about Java streams. So if you've done my course on functional programming, then streams will be very easy for you to understand. But basically, we move away from imperative to functional programming. So instead of us defining every single implementation detail, we'll just tell it what we want. Now, streams are mainly used with collections. So if you know about lists, arrays, sets, maps, and all that good stuff, then you should be good in understanding streams. Otherwise, check my course on Java where I go over the collections API. So you know what a stream is, but how do we exactly use a stream? So let me actually help you to visualize, and hopefully this will make sense. So to use a stream, we need to start with a collection. So this could be arrays, sets, lists, maps, and other implementations. So now that you have your starting point, then what we do is from the list itself, we invoke the stream method. Now from this point onwards, we can have as many streams as we want. So we can have a stream 1, 2, 3, so on and so forth. Now these streams right here, so this is the abstraction phase. So this is telling what we want. So this is the abstraction phase, right? So instead of implementing every single implementation detail, we just tell it what we want instead of defining and controlling every single aspect of the logic itself. Now, the stream itself right here, and in this course, you're going to learn about streams and all the methods available. But when you invoke the stream on a list or a collection, you can have methods such as filter to filter down elements. You can map for transformations and also reduce. So these three right here are three of many methods available to us. And don't worry, we're going to cover the most important ones, and by the end. Now, something to bear in mind, you should know exactly how to work with all of filter, map, reduce, so on and so forth, and everything which you can invoke the stream upon. These are called the intermediate operators. Again, keep this in mind. So these are intermediate operators, right? Then once you are done with your streams, and you can have as many as you want, you then pretty much just say, right, so now that I've got my stream, I want to go back to a concrete implementation. And this is going back, for example, to a list, an integer, an object, an optional string, and any other data type, right? So these are methods available such as sum, collecting to a list, performing average, grouping by, so on and so forth. And you'll learn about all of this in this course. Now, I said that the streams itself, those are the intermediate operators. And at the very end, when you want to collect or you want to go back to a concrete class or type, these are called terminal operators. And terminal because they end the stream and then they give you back what you pretty much have requested from the sequence of streams. And this is pretty much how they work. As I said, don't worry, we're going to cover everything in detail and all the methods available. But if you have any questions, please do let me know. Otherwise, let's carry on. So within examples, let me create a new file in here. And what I'm going to do is I'm going to call this as working with and then streams. So inside of this class in here, let me show you how to work with streams. So here, let me just have a test. So new test method, and I'm going to say streams. There we go. And let me collapse this. So to work with a stream is as follows. So remember I said that we basically start with a list, array, set, so on and so forth. So let's have a list in here, and this will be a list of strings, just like that. And let me just say names in here equals to list dot and then of, and in here let me say amigos code and then Alex, and let's just say Zara, for example, right? So obviously this could be anything that you want, but as I said, when you want to work with streams, you basically use a collection, and then from it you can invoke the streams. So here I can say names dot and then have a look, stream. There we go. Now this in itself, if I extract this to a variable, have a look. So that is a stream of strings. So this is the exact same thing of you saying stream. There we go. And you can specify the data type. And then I'm going to say names, or basically names and then stream equals to, and then stream dot. And then we have a look, concat of, or empty, generate, so on and so forth. You can even use the builder. But here I can say of and then values, and I can give the exact same values in here, right? Oops. So basically just like that. So this is the exact same thing, but what I'm doing is from the list itself, I'm pulling out the stream right here. Now from our stream, remember I said we can have multiple of methods, right? So here I can say stream and then dot. And now have a look. I've got map, filter, collect, limit, sorted, take while, distinct, on all of these methods, right? But what I want you to see is, have a look, distinct, it gives you back a stream. Take while, it gives you back a stream. Sorted gives you back a stream. Limit gives you back a stream. Flat map, a stream, so on and so forth. So this means that in here you can actually, so let me just say limit, for example, and then 2. I can then say dot, and then basically I can concatenate these streams together, right? I can say map, for example. Oops. So map, for example, let me just say no in here. If I can, yes. So that's not correct, but all I'm showing is that I can say dot and then sorted, null. And you'll learn how to use all of these in a second, but I'm just showing you. So basically you see that I'm actually able to concatenate these streams together. And once I'm done, so here, so this is the stream, then we invoke, so limit, map, so on and so forth. And then at the end, we say dot and then collect. So these are the terminal operators. So let me just say to list. And right here, so if I extract this to a variable, have a look. So we have from a stream, we piped a bunch of streams together to tell it what we want, and then we collect it back to a list of objects. Now this doesn't do anything, I'm just showing you how it works, but I'm going to give you real examples in a second. All I want to say is that these are the intermediate operators. And then once you are done, you say collect, and this is the terminal operator. So I can even say, for example, so if I delete this, so I can delete this and then say, for example, count. So count, have a look. Count gives me a long and not a list back. Have a look, right? So count is also a terminal operator. If you want to collect back to a set, you can also do it to a map using grouping by, but don't worry, I'm going to teach you all of that in a second. Finally, what I want to show you is in this course, we're going to use both lists and arrays. So if you have an array, so here, if I say string and then names and then array equals to, and I'm missing curly brackets here. So if I just have an empty array just for now, so if I say names dot, so here, have a look, I can say stream, and what this does, have a look. So basically this was auto completion, but basically I cannot invoke stream directly into this array. I cannot say this. So stream, you can see that IntelliJ is telling me what I need to do, right? So instead I need to say arrays dot stream, and that will give me back a stream that I can then, so here, have a look, I can say filter, map, collect, so on and so forth, right? So this is pretty much how you get a stream from an array. Now this right here doesn't do anything. As I said, I'm just showing you how to get started with streams. But in this course, I'm going to give you real examples, and by the end of it, you will master the Streams API. Let's begin this course with an exercise. So open up the Getting Started class in here inside of tests. And what I want you to do is to complete this method in here. So find people age less or equal to 18, then change the implementation to find the first 10 right here. So basically there's a bunch of people inside of this list. So find the ones which are less or equal to 18, so the actual age, and then change your implementation to only return the first 10 people. So go ahead and give that a go. And again, here we're not learning about streams, and this is me showing you the imperative approach, which then will lead us to declarative approach using streams. Give that a go, and I'm going to give you the solution in the next video. All right, let me give you the solution for the exercise. In here, what I did was I created one list right here called young people and initialized to an empty list. Then I do have two variables. So one, which is the limit right here, which is 10. And then the other one is the counter. So this is so that I can only add 10 people into this list right here. And then what I have is the for loop for the initial list. Then I check whether the age is less or equal to 18. If so, I add the person to the new list called young people. And then here I increment the counter, and then I check if the counter is equal to the limit. If so, then I break out of the loop. And finally in here, so line 31, I do log or print out to the console the results. So here, if I run this test, so run, there we go. You can see that. So the output, have a look. So we have in here, but if you look at the age in here, you'll see that we only have a couple of people back, and their age is either 18 or less. So there we have it. So this, you can see that it's a pretty lengthy solution. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 lines of code for something very simple. And to be honest, we can do something way better than this using the declarative approach with streams. Join me in the next video. So within the same file, Getting Started, in here we do have this empty test, and this is using declarative approach and streams. So what we're going to do is we're going to implement the exact same problem that we have in here, but using streams. So in here, remember I said that we start from a concrete class. So our concrete class is people in here. Now, what we need to do is from the concrete, we go to the abstraction. So here I'm going to say people dot and then stream. From this point onwards, I can have as many intermediate operators, and then the final one, which is to collect the results back, is the terminal operator. So the way that we can replace the above implementation with streams is as follows. So here dot, and then in here you can see that we have a bunch of methods that we're going to learn throughout this course, and the one that I want is filter, and inside this takes a predicate. So the predicate receives the person, so I'm going to say P for person, and then it returns a lambda, and here this, or actually it takes a lambda, and the result has to be a boolean because it's a predicate. Now here I'm going to say P dot and then get and then age is less or equal to 18 right here. And then what I also want to do is say dot and then limit to 10. And finally, my terminal operator is dot collect and then to list right here. And to be honest, this is it. So now let me actually put this on a new line so you can see everything properly. New line here, the same here, and then let me extract this to a variable. So now I'm going to call this as young and then people, same as before. And finally, we can have the exact same loop. So here, let me just paste that, and there we go. So don't worry if you don't understand this, but basically what we're doing is from the concrete class in here, which is a list. So this is our starting point. We go from the starting point to this abstraction, which is using stream. Then we have two intermediate operations in here, so filter and limit. And then finally, we collect back the results to a type that we can then use, which is a list of people. So this is the result. And then finally, we print out the result. So if I run this, this will give me the exact same result. There we go. You can see that we have the exact same result in here. And if I close this, you can see that the implementation in here, it's much more elegant than doing all of this logic. So you can see that here we have to define, an extra list, and then two variables, and then a for loop, within a for loop, an if statement, increment the counter, adding to the list, checking whether the counter equals to the limit, and then break. So you can see how we have to deal with every single part right here. So you can see we have to define every single implementation detail. Whereas with streams in here, so the declarative approach, we just tell it what we want instead of defining every single step and moving parts for what we want. And this is streams in a nutshell. Don't worry too much about filter, limit, collect, because we're going to learn all of this in this course, but you can see the power of Java streams. If you have any questions, please do let me know. Otherwise, catch me on the next one. So you saw how declarative approach is much easier and intuitive to write, and it simplifies a lot of things and removes all of the moving parts that we have to implement ourselves. Now, what I want to show you is how to visualize what is happening with streams. So basically you saw that we have filter, limit, and then collectors right here. So what I want to show you is there's a nice feature within IntelliJ, and that is if I stick a breakpoint in here and then right click and then debug. So let's run this together and have a look. So it just stopped in here, right? And if I put this full screen, have a look, we have this button right here and trace current stream chain. So I'm going to click on that now, or in fact, I don't even need to put this full screen, but have a look. So I can hide that for now and maybe put this bigger, and there we go. So have a look what is happening in here. So we have people.stream, Then with filter, so if I click on filter, have a look. This is actually showing me what is happening, which is kind of cool, right? So basically it filtered, so all of these people right here, and then we have 10 because of limit. Have a look. So we limit into 10 people, and then we say collect, and then we have an array list of 10 elements. So this is really cool. So if I click on flat mode, you can see that this is actually giving me the entire flow. So we have the data, we filter right here, and then we limit into 10 people, and then we collect down. This is all for now. Catch me on the next one.